Just to start off the show, I would like to call upon Engineer Anuj Raizala. Then we have Engineer Amit Gupta. Then we have Dr. Hardesh Khanna. We have PVSN Murthy, and we have Anupam Saxena, and also we have Anis Ahmad on the stage. So now we start off the session, the second half day of the session, and at first I would like to invite PVSN Murthy, Regional Director, Honorable Ambassador Director, Regional Energy and Promotion Association, for immediate guest of honor and special entrance.
Good afternoon, ladies and gentlemen. I thank Professor Iyer and BCCI for giving this opportunity to be here and talk about the hydropower in Bhutan. The subject is hydropower renewable. Well, hydropower, the basic source is what? Water. Water is the one, the day starts for us with water, the day ends with water. You need water. We are getting everything from water here in this room today. So it's a very passionate subject. Any hydro engineer needs to be very passionate about water, its implications, how we can use the water for the betterment of the generations, and what is going to leave for the future generations. When we are talking about renewable, basically I will say renewable, that means you are able to utilize the same resource not only for the present generation, and you are going to leave it for the future generations also. Though hydropower as a business model it works, the power generation, at the same time everyone has a social responsibility to the society where we have born and what we are going to leave for our next generations. So we have to look into that aspect of power generation from this aspect also. Definitely, as Mr. B.P. Rao told in the morning, many countries have declared hydropower as renewable energy. In India, still we have to declare large and medium as renewable, though up to 25 megawatt it's covered under renewable energy. You see, the water is helpful to you. At the same time, the devastation in Uttarakhand in India shows that water can be also a destroyer for you if it is not harnessed properly. So let's look into the aspects. The hydropower is not only for water is used not only for the power generation. Water has immense potential of doing irrigation, which is very important. And then the water flow needs to be controlled for the flood purposes. So how do you achieve this part of it? So in the initial planning of the countries, if you see, the major thing started with the dam projects. The purpose of these dam projects is not only hydropower generation, they are multi-purpose projects as we call it. And they are used for the power generation, irrigation purpose for the canals, and flood controls. These are the three major items through which these dam projects have been developed over the years. Well, the next is what we call the run-of-the-river projects. These are much simple projects where you are not constructing any obstruction, you are not storing the water, but you are diverting the flow of water and generating the power and trying to bring it back to the river base, river flow back into the system. So in this run-of-the-river projects is the one where we are talking about when you have got parallelly so many run-of-the-river projects, there could be some ecological imbalances that will come. That's where the geologists and the hydrologists need to get into the detailing of how the ecology and environment is not getting affected because of the development of these hydro projects. This is very critical in the design of a hydro project. And that's where some of the system in Uttarakhand has come because of the series of some of the run-of-the-river projects which have come in the field. If you see, after the privatization in India, most of the hydro projects are run-of-the-river projects. Storage projects are very less. So that is Means we have gone into development of run-of-the-river projects in a big way, and we do not know, but environmentalists, the NGOs are saying that there are reasons where it has affected the ecological conditions. So these are all reasons where we need to get into detailing of this particular part of it, and specifically the geologists and hydrologists have a lot of effort need to be done in the design of this type of plants. Of course, now along with the hydro projects coming up, there is the what we call the sustainability of the projects. There is a lot of work going on this sustainability, internationally also, and there is sustainability guidelines are being worked out, and projects from the conceptual stage till the operational stage are being audited under this aspect, and they are marked differently, and that gives you the rating of the project, whether they are taking care of the R&R problems, what is the ecological problems they are taking care of or not, and the sustainability. This has been initiated by International Hydro Association along with some of the main suppliers of the equipment as well as developers in the European Union. And incidentally, some of the Indian projects have been audited for this, but all these audits are confidential, they are not being publicized. I was part of one of the projects which has been audited in India, so that's how we are aware of it, but there is a condition when we sign with the client that it cannot be publicized unless the client accepts it to be publicized in the domain or in the public this one. But there is a lot of work going on in this effort. That means the developers who are going to come up with the hydro projects need to have understanding of this sustainability and sustainability laws. As I understand, Bhutan has a Sustainability Act, so some of these things normally might have been incorporated into the system and which needs to be internationally checked with the sustainability practices which are being practiced now in a way. And I do hope in a short time of time the sustainability of standards will come up. So all this brings us that hydro is a renewable energy, but it's for us how we use this water. Water is the main resource. Water, what we are using today for us, for the benefit of the mankind. It's not only for us, but what you are going to give to your next generation, what you are going to leave. So the renewable energy emphasis is towards what you are going to leave for your next generation. In a thermal, you are taking out all the coal, you don't know what you are leaving for your future generations underneath. Whereas the renewable energy will leave future generations also with abundance of water and sunlight. That is one of the social responsibility of each and every individual on this earth, and that's what I feel when we talk about renewable hydropower and the renewable energy. Let's all together work towards that, and it's very important. That's what I would like to share, rather than everybody shared a lot of numbers, figures, and everything. So I would like to be different, and I want to talk about comparison of water. You have to be very compassionate to be a hydropower engineer. Thank you very much.
So, again, just continuing the session, I would like to call upon Mr. Willy Hammer, Managing Director of Conclave, for a brief introduction of German town.
Ladies and gentlemen, Mr. Willy Hammer is an entrepreneur who has built up one of the most remarkable companies in Germany, in Regensdorf, on photovoltaic and solar systems. Tomorrow we are going to go into detail about our solar presentations, and we will show you some of the very interesting examples on complete renewable systems, renewable energies, and how we utilize them practically. I mean, you are seeing a lot of, hearing a lot of things and seeing a lot of presentations, but what it means to do it in practice and in the reality, and how you do it efficiently, in which manner you can structure these projects, and how you can develop a micro project in that sense, which is very fast and very efficient. These will be all shown in our presentation tomorrow. Willy Hammer is the managing director of ENFRAtv in Germany, in Regensdorf. And let's welcome him over here to speak a little bit about himself. So, Mr. Willie Harmer, it's your
use this. Good afternoon, ladies and gentlemen. I'm glad to have become the possibility for you for inviting here in Bhutan, in this nice area in Bhutan. I've seen so much nice things and so much natural things, and I thank you very much that I can be here. Today I want to give you a short statement about solar energy, because tomorrow I will present together with Dr. Kana a presentation for my company, for our company in Germany. And now to me. Okay. So, yes, I am a German. And yes, I'm married since 29 years. Yes, I have 2 adult children, and my company is in Germany. We made solar technologies and other technologies, mostly solar technologies, since nearly 13 years. 13 years is not a long time, but for us it's a very long time because we have always stress. Germany has the rules and regulations to make solar energy for all people now. We have made in this time, 13 years, 3,700 projects, small ones, bigger plants. As you become here, I think, Professor, here in Bhutan, it will come, and naturally also in India. Yes, we have a global warming. The first time when I was here, our drivers speak to me and says it to me. Global warming is true. Yes, it's true. No, we make no fossil and carbon energy in our region. We make only solar energy. And I say to you, it's possible. It's possible, and it's a simple thing. Tomorrow we show it to you. It's very simple. True is that solar energy is now very cheap. It's becoming very cheap because the Germans and the US are the first who did it. Also India, I know. But in Germany we make every year nearly 7 gigawatt. 7 gigawatt. 5 years ago, solar technology was very expensive. 4 times higher than now. And now you have the chance to get the experience what we have in a shorter time, and for cheap money. It's very cheap. Now to use the product current for our own. Now we make little houses. Before we make industrial plants, now we make all the houses in our region, in Bavaria, it's in the south of Germany, and everybody wants to have it. Not everybody, but every second. And we have much people who have this now on the roofs, and they did it the second time, because we make it on the roof, we make it now on the garage, on the cardboard, everywhere where they can make current. Not only in the south. Germany is not the land. We live not in south like you here. We have half the electricity capacity than you. We make it. And you have the sun for nearly 365 days a year to use this power, and it costs nothing. No, only your energy. And now I think it's time to use and to become the energy to get solar on the roofs, on the free fields. There are much things you can do. Thank you very much to be here. Thank you.
Thank you, sir. For now, for the next session, I would like to call upon Sri Kumar for presentation for momentum quality.
Good afternoon again. So we start this second part of the session with acknowledgement to all our sponsors who made this event happen. And so we call upon firstly Mr. VP Rao, his representative from BHEL to come over and collect this memento. Yeah. And Mr. Dr. Khanna to come and give this moment. You're very hard. Yeah. Second, we have on the list as WAP course for being a co-sponsor. Please come over and.
What was the second part of
Yeah, second part. Next we can call upon the team of BHEL to be represented by
Can
the
you
team.
entire team come over?
Yeah. Mr. Willie, can you give this? Oh. Yeah, yeah. There's a team of BHEL, which is this main sponsor of the event.
I think you can stand this way.
You can move this side, really. You can face this.
Next we call upon the representative of HCC, who has been our co-partner. Next we call upon Messrs. JP, and we request
Anybody from JP? Yes.
Mr. Cook Sherry to kindly. Lastly, we call upon the segment partner, Messrs. Ross from Germany, to take this memento, and we request our benevolent professor to come over and give this.
I think Shri Kumar, we all can do it.
Okay. Yeah.
Come, get it.
Okay.
Thank you, and now we continue with the program.
To continue the program, now I would like to call one engineer, Amit Gupta, Senior Project Manager of the conjunction.
I think pointer is stuck.
load there, not it is a voice load.
I'm sorry for the delay, gentlemen. The distinguished eminent personalities on the dais and august gathering, a very good afternoon to all of you. Kusazampula. This is Amit Gupta, Chief Civil and presently working as a Senior Project Manager on a 1200 megawatt project in Bhutan. I'll basically talk about the VAPCOS, the company which I'm representing today in Bhutan. And we'll discuss and share a few of our experiences, good or bad, I leave it to you, towards the successful and accelerated development of hydropower projects. Before I really get into the thick of the skin, just a word about myself. VAPCOS is a synonym of water and power. Anything and everything to do with water and power is VAPCOS. Established June 69, almost 4 long decades. And we are specialized in the fields of water resource sector, the power and infrastructure. And today I'll touch only the tip of this iceberg, that is hydroelectric projects. The spectrum of services which are covered right from concept to commissioning. At the grassroots level, from preliminary investigations and reconnaissance surveys, the feasibility studies, baseline and socioeconomic surveys, the field investigations and testing, design engineering, tender engineering, contract management, operation and maintenance, and more importantly, the institutional building, the human resource development. I will not confuse you with where is the head office, where are the regional offices, what is the turnover since past few decades, blah blah and everything. It's available on the click of the mouse on internet. But yes, in nutshell, 47 hydropower projects successfully completed and executed, commissioned, across 7 countries on this planet. Total aggregate capacity of 20,000 megawatts. And very proudly, VAPCOS is a brand name in itself on this Asiatic continent and has already established the footsteps in Bhutan. We are proud to state that the hydropower success in Bhutan and our association are almost for the past 4 decades. With 3 projects, 1500 megawatts, as we have been hearing time and again since morning. 3 projects slightly short of 3000 megawatts which are ongoing, and 3 of them upcoming, wherein we are anticipating our direct association with the projects. And more importantly, technical things apart, commercial things aside, we want to be the part of these smiles. And our association in Bhutan, as I said, started way back Chuka in 1970s or so. Tashidele. Thanks a lot. Thanks a lot.
Beautiful presentation.
Thank you so much. And next we have PHE presentation on accelerated hydraulic design and development of hydro turbine by and Anish Ahmed.
Hello everyone, I am Anish Ahmed, hydraulic designer, HydroLab PHA Bhopal. The topic of my presentation is accelerated hydraulic design and development of hydro turbines. So before going into the presentation, let us have a quick look over the contents of the presentation. First of all, I would be introducing you about the topic of the presentation. Then I will be telling you about hydraulic design. Then I would be throwing some light on the CFD analysis, and after that conclusion would be there. So in olden days, when the technology was not so much evolved, hydraulic design of hydro turbines was a long and slow process. Why it was long and slow? Because there were no CFD tools, and in order to evaluate the performance parameters of a hydraulic turbine, it was to be experimentally tested on test beds. And there was no other option other than that. There was no CFD, there was no computer-aided design. But now the scenario has altogether changed. With CAD and CFD, they have accelerated the hydraulic design and optimization also. And not only this, it has increased the efficiency of hydro turbines also. Prior to CFD and CAD, the efficiency was about 90 to 92% for hydro turbines, but now we have achieved from 95 to 96%. Why it was possible? Because using CFD and computer-aided design, we were able to calculate the component losses. Prior to that, when only testing was there, we were not able to calculate individual component losses. And after optimizing a particular component, we were able to increase the efficiency of the hydro turbine. Apart from this, using CFD, we can design a number of variants for a particular design. We can make a number of variants, from 15 to 20 variants can be made. And the best variant, which we think that this is the best one, we can choose. Now you can see this is a typical diagram of a powerhouse. Water is entering into the turbine and moving the runner. What is happening here, the kinetic or potential energy of the water is converted into the mechanical energy of the runner. So what is hydraulic design? The design of this path, hydraulic path, where this energy conversion is taking place, is actually hydraulic design. Now, hydraulic design is actually a heart of any hydraulic turbine. This is because all the performance parameters like efficiency, power output, cavitation characteristics, turbine settings, all could be proper only when the hydraulic design is proper. Now, need of hydraulic design. What is the need? The primary data which we need for designing a hydro turbine are type of machine, available head, power output which is based on discharge, and speed. Now, why do we need these data each and every time? Because every site has a unique discharge and available head. And for a unique head and unique discharge, we need a unique hydraulic passage to be designed. A good example of this is Kunal Sangchu 1 and 2. Both are on the same river, but both have different hydraulic designs. Now, this is a diagram which compares the Francis turbine relative shapes for a low head Francis turbine and a high head Francis turbine. You can see the difference. For a low head Francis turbine, we have a big casing, we have a more hydraulic passage, and to accommodate more discharge. And you can also compare the runners. Both runners are different. The inlet edge of both runners are placed at different locations. Now, what are the objectives for this hydraulic design? First of all, minimum loss of energy should be there in the hydraulic passage. And secondly, all the components, for example, spiral casing, stay-in, guide-in, runner, draft tube, should be optimized individually. And component to component matching should be there. For example, stay-in to guide-in to runner, these components should match with each other. Now, this is a hydraulic development process flow chart which we follow in HL. First of all, we do the hydraulic design. After that, we do the CFD analysis. And we check whether it is suiting the data or not, the data, site data like efficiency, power output, etc. And if it is okay, we optimize the profile by doing CFD analysis. So, in order to solve this, we cannot use one computer. We have to use a number of computers. So, what we do that we put a number of computers in parallel and solve the problem parallelly. And we are having the latest parallel processing technology in BHEL. And also, high performance cluster is dedicated for CFD analysis. Also, all the CFD results are validated with the test results in the test lab after model testing. So, conclusion: optimized design of hydro turbines is very necessary in order to ensure the fullest utilization of nation's precious natural resource. Secondly, advanced numerical simulation like CFD analysis can be used to increase the efficiency and the operating range of the hydro turbine, and can be used to decrease the ill effects of cavitation and erosion with desired unit speed and unit discharge. And also, hydro turbine design using CFD analysis has more reliability, stability, and takes less time to get delivered. Thank you.
This in the morning, you had mentioned that, our government policy should be friendly to the private investors or investors. So I think that's a very good advice from your side. And then also in the morning, Dr. kindly said that, we are not represented by the government today because it is in the transition period. So, and also Dr. Iyer, Professor Iyer mentioned that there is a big potential between the private sector of India and Bhutan to work in associations and explore the hydropower potentials of Bhutan. And now we are very fortunate that Mr. Bhaga, he is the head of task force of hydropower from the GNS Commission. So I was wondering that what would be your advice to make our policy hydropower friendly? That's the question for you. And to the where I would like to ask that, okay, you have been doing a fantastic good works for the mega projects. Do you have anything in your agenda for the small entrepreneurs? That's the question for where. And then also to the workforce, one question that have you also thought anything to develop the private sector and this like smaller entrepreneurs in the hydropower sectors to garner the potentials of the hydropower in Bhutan? Thank you.
Okay, first to you or to me?
Yes, I think you can start from you.
Okay. It's a very good question which you have put, and I'm glad that you have put it because I think that is the basic of any renewable project which you can start anywhere. So there are various models for doing it. India has gone slightly a different way than Japan and Germany have gone actually, because Japan and Germany have fixed in FIT, so that means feed-in tariffs. So these feed-in tariffs represents the dissipation of the carbon dioxide into the atmosphere actually, so they take that into account. Whereas India has a model of RECs on the private sector, I think, if I'm not mistaken, and they have also a partial tariff structure over there depending on state to state, because it's not federal everywhere, it is the MNRE decides to some extent. This is what I am aware of. So there are various models based on the capex which you are going to put in, and what is the feed-in tariff, and what is your depreciation model on that actually. See? So this could be integrated into the policy, especially taking into consideration how much carbon content you are reducing, or we have the certificates, you see the renewable energy certificates which are being promoted. Other areas are, they give on a capex a subsidy if you have installed somewhere, and so it all depends, you have to optimize, but at least you should know what is the basis of your power generation and what will be the feed-in tariff applicable to that power generation, so we could advise you on that in a specific way, looking at the scenario with which you would like to go. Because finally, you are looking at a capacity, let's say we are looking at 4 gigawatt as we are based over here for the next 2020. So that means in 10 years. Now how are you going to accommodate that 4 gigawatt in 10 years? So you have to calculate the capex cost and the pollution factor on top of that, which you will be saving by applying that. So in that way, World Bank also has certain programs over there, so we can have a trade-off between those emissions which you are going to protect, and what are the energy units which you are going to create actually. So these are various models, and these have to be then specified in a legal structure, and then only the people can invest and plan accordingly. Otherwise they cannot plan an investment. So let's say if you're planning an investment of, we have been talking today, these big projects, actually it's a very different scenario when we are talking about 300 megawatts or 200 megawatts and different financing which you cannot compare in the solar area. Because solar area, when we are talking about big power projects, they can be from 1 megawatt onwards, the pricing structure changes completely actually. So below 1 megawatt, the pricing structure is different. Today, when we look at the world scenario, the projects which are taking more and more in installation are below 1 megawatt actually, because the projects above 1 megawatt also requires a lot of space. So the question is how much space you have available. So all these things have to be taken into consideration, because again, so rooftop concept is a very, very user-friendly concept actually, because it's a decentralized concept where you can have an island mode production. So you are not making a lot of burden on your grid in that sense, you know. So when I am looking at the structure of Bhutan, I think it will be much more favorable to think on those lines, like you see, because there are two considerations for Bhutan. You have a country where I think your temperatures go up to -5 to -10 degrees Celsius. And then if you're looking at that and you're looking at average temperature of 10 degrees per year, per day, roughly, so that means you need a lot of heating capacity over here. So I would be looking from the first of the heating capacity, because you need warm water and heat over here. So that is energy which you will save from other means, coal or whatever it is, you see. The second part is the power part, actually, the photovoltaic part. So the photovoltaic part, actually, if you use more photovoltaics for personal utilization or you re-export it, you are giving yourself more allowance to export your hydropower. So all this mix you have to balance and see how you can develop that sort of a policy so that there's a trade-off and there's a revenue stream coming in actually. So all these are considerations which you have to think of.
I want to correct, I'm sorry, actually his question, Lama's question was from hydropower. Lama's question was on hydropower because
Excuse me, was it on hydropower?
just a minute, his question was on hydropower, not on solar, if I'm right. Am I right?
Yes.
Okay, so first, let me address that issue, because solar comes later, because right now his question was hydropower. So can I answer your question?
Yes.
Okay, so in the morning, you were there in this whole session when I answered, when I said, I had already given the solution, and in fact, yesterday, 3 of us were on the PBS, and we had given the same solution on PBS. See, what Dr. Khanna was saying is the secondary part of the full solution. The primary part of the solution which you are asking is, what do we do with the hydropower development model? Is there a policy construct which can be designed to accommodate private sector? I hope
Yes,
I understood you rightly.
Yes.
And my answer to that was very clear in the morning, that it cannot be that you jump to the 1200 and 1000 megawatt to do the thing. You start with a very nice one, like you make a model up to 100 megawatt. Now up to 100 megawatt, you continue to build those projects and gain some experiences. And I do not know whether HL has a turbine of that size, but definitely you have, in India I can give you manufacturers. Kirloskar has got it. In fact, Voith has got it, if I'm not mistaken. And there are a few others who have got this kind of capacity. So machine availability is not a problem. The problem is, and in India all the competition is there. So machine availability will not be a problem. That solution is clear for any contractor or any constructor or any developer in Bhutan. Getting technology which is competitive and good is not a problem. So now comes the next thing. What happens to policy construct? The policy must recognize the economic involvement. And the economic involvement, we have the friend from the Gross National Happiness Commission, right? So economic involvement and bringing that gross national happiness will not come for both the countries unless the people of India and as well as Bhutan engage in the development of both the countries. So in that principle, there is every role for the private sector of Bhutan. So this must be impressed upon the policymakers. And this has taken a little longer time. But I think if the right minds meet together and we work together, there will be enough confidence on both sides, including the India side, Bhutan side, and the people side, and the engineering side. And this will not take a very long time now, if you put it forward in the right way. So the policy construct will only develop if you tell the policymakers what you want. If you take all the stakeholders into confidence. And right now, I feel, somewhere we are all in a game of fence sitting, Oh, that's the mistake of that side. Oh, this is the mistake of that side. So I think we come out of this whole game of fence sitting and put a constructive effort. May not be if it does not come from the government. Let this forum, I'm ready to help you. Let us create something and officially go and give it to them for consideration. There's no problem if they have a different view. They open it up, they change it. That is the dialogue part. That is the negotiating principle. The whole principle is, at the end of the day, I'm very clear. Again, I reiterate, without private involvement, no, and enterprise involvement, no country in the world, not only Bhutan, India, can develop. That model will remain a bunch of people enjoying it, and limited involvement model means people do not benefit in the long run in such development. So for which, important to look at policy construct, legal issues, and other issues. And now I will come to what Khanna was saying. Dr. Khanna was trying to tell you that you have a very long gestation. This is what we told yesterday on BBS. HydroPower projects take 8 to 9 to 10 years, depending on the complexity, depending on the nature of the terrain, and we are not working in easy mountains. We are working in the geological terrain of the Himalayan region, the highest mountains in the world. So understanding this difficulty of not quickening it up, but making a short development model, we need a currency flow for Bhutan. That is the problem. So the currency flow solution comes from solar. A solar project like 214 megawatt, largest solar park developed in India in Gujarat at Charanka village at the border of Pakistan on the Kutch region, where I was invited by the Modi government, was developed in 1 year. 214 megawatt in 1 year. So that means you're putting that much of power into the grid in quick time. That means you're not going through the big difficulty of interest during construction, and you have a commercialization model of deliverable of power. Now, when I give you the solution, the next answer is, Professor, how do we sell to India 6 rupees 50 paisa electricity? Okay, I'm telling you, we were trying to sell 22 rupees electricity before. So today 6 rupees 50 paisa is feasible, not on direct sale. Here it can be a model where you attract investment and use the energy exchange mechanism. So India will have no problem, because this has not got to do with the hydropower issue. It is not the bilateral deal. It is more of a, from the power trading, you go to the exchange mechanism where market-based electricity comes into picture. Now another question will come, is the grid transportability between India and Bhutan capable of absorbing this? Then I tell you, this is like an extremely silly question if somebody asks, because you're talking of several megawatts hydropower, and this is a very small component which goes in and does power pooling. What is power pooling? If hydroelectricity is 2 rupees, actually you're putting this 6 rupees 50 paisa, you will only expand to 5% of that component of electricity for quick rupee gain for yourself. And this is the only method by which you can offset the vagaries of hydropower development. And this has a great role for private sector, because again you will have all the solar guys coming in, constructing, you can assemble, you can have easy assembly. Solar is not as complicated as hydro. I had given all this route yesterday. We will also come and give this solution. I think, as I told you, Fubzan was there in the morning, you are there now. I feel all of you get together, and I advised also that instead of 45 people's consortium, make it a holding. I have discussed this with you. Get 4 or 5 entities, compete within yourself, make your government confident, and then you will grow forward. I don't think anybody will have any problems with this.
This is the information for your own self. So whatever you are generating, you get additional capacity to export that also. So you are killing 2 birds with 1 stone. On one side you are exporting and keeping whatever contractual obligations you have, and increasing that revenue stream.
But there is a problem here.
Okay.
India cannot buy that electricity under government-to-government mechanism.
No, I'm
Because we
talking
are
about
buying-
the hydropower now.
No, even solar, they will not buy. Who will buy the electricity?
No, the solar is on the private sector, on the exchange, that's what you're saying.
Yeah, that's what I'm clarifying.
So, you are, the second bird which you're killing is that you are increasing your revenue on that, you see, so this is the answer to that. So if you have a legal framework for that, within your country, that means you are promoting the power generation into the country, and it's a viable solution for the private entrepreneurs. That's what I want to add.
Yeah, but as I told you very clearly, you need steel and cement plants to also consume it. So kindly do not forget that the private sector of Bhutan will also start making steel and cement, basic commodities that go into construction. We need to have a very good long-term plan, looking at what you use and where the energy consumption will also have an internal. You need to increase your own consumption model to grow your GDP.
thank you, Dr. Khanna and Professor Iyer. Thank you very much for this clarification and advice. I also like, in continuation to this, before we get the response from Marcos and Gail, I also like post professor's advice of the legal framework and also World Bank's trade-off concessions. I think these are things, and I just wanted to know, like, of course, off the hat, the views of our DNS Commission.
I think Professor Iyer has made it very clear. The onus is for the private sector to come up with your proposal. The government has an open arm policy. As you would recall, the express policy of the government has always been to intake and encourage private sector growth and participation. Even in the last 5 years, when we initiated the 3 mega projects, Pune 1 and Pune 2 and all issue, the government had been encouraging and looking forward for private sector to participate as a consortium, as an individual who are unable to, but for whatever reasons the private sector failed to even to take part in the construction aspect of the HydroPower or the power projects, let alone in development. So definitely the government would be receptive, that's what I feel. And as you have rightly mentioned, I have been engaged over the last few months in leading a multi-sectoral task force in doing a strategic assessment of the 10,000 megawatts. And even in that part of that exercise, we have been trying to discuss and bring forward the views of the private sector. So definitely we would welcome any proposal from your side.
To answer the question from EHL perspective, we are definitely not into owning and operating the mini and micro hydropower plant as of yet. But definitely we are in position to supply you equipment, that is electromechanical equipment for small power plants also. Normally we do not manufacture power plant equipment less than 5 megawatts, but there is
Really good transitions to be heard. I would be interested to know. For example, I think we're in the process of building the institutional capacity building of the Bhutanese, and I'm just wondering that if, if we could consider setting up some small workshop and manufacturing things on the small things, because I think it would be good. We would like to build our own institutional capacity, and I don't know whether we would be interested to try up with our private sector to develop us, and especially for the small power batch and equipment initiatives.
Absolutely. Right now there is an initiative which has been taken up by DHL and DPPC jointly. We are trying to set up an electrical workshop here for the repair of generator and transformer, spare parts and other things. We wanted to set up a manufacturing plant for Kanas also, but that is conducting 3 training sessions for DCPC staff. We will invite BBC and other private sector entities too. Talks are also going on, where we can trainings on windings, repairing, and some machining and all those things. So definitely we are open to all kinds of cooperation.
I also want to say, I had one morning we had a discussion with the DHL chair, and I have impressed upon him that if REPA, which is a not-for-profit body, the Renewable Association, we will bring a 1-year kind of a diploma or a training course for training people in Bhutan. So that's the whole thing, when you raise the standard up, automatically the bar is up, and it will be easy for experts like him from the GNS country straight away, say now you qualified. That's the only thing, once you come to a different level, you can handle the job, you can get the engineers. I don't think it is very difficult to do it. The whole problem, even in India, when I'm discussing with a lot of people, is we are failing to get good civil engineers for doing construction design. We are getting into problems of execution. People don't want to live in tough conditions, then employ compensation in the tough condition. On one side, we are looking at nice air-conditioned jobs. On the other side, we want people to slog in those remote areas.
So all of these issues will be coming in, human issues are just not handleable. So your kids and wives are far away, and then there is pressure of the family and everything, and you are there at the site for 20 days, and you come and see the face of your kid and everything for a few days. So these challenges will come, whether those engineers will stay. So you'll have something called the employee turnover ratio. Huge amount of people after 1 or 2 years are trying to shift from tougher jobs to easier jobs. So I think you have to be ready for all this, and it is not an easy time. So it is not a time to complain. It's a time to tackle and understand these issues and build together, because these issues will be common to both of us, common to Europe also, common to every place, because people want better lifestyle. And in the process, they don't think projects offer them a better lifestyle. You know, projects build nations. But what is happening? While projects build nations, people who are youngsters, they are not told that these projects are important and you need to give your time and a little bit of sacrifice. So I think there must be scientific design of compensation of people who work at sites. So complex issues are going to get involved. And you as contractors, your challenge is from contracting mindset as owners to actually an empathetic mindset of involvement. That is where you'll have to go. If you don't go to that direction, you will lose your best people. There will be huge bloodbath and competition. It's not only in India, the whole world is looking at it. They will take the best engineers away and they will pay them better money and take it. The game will be over. You will build them and they will go somewhere else. That will be the next challenge.
There was a question over there.
Yeah.
Go ahead.
Registering from construction association, since you all are construction sector, I would love to
I can hardly hear you. Take the microphone.
I am from construction association, and since you all are from construction business, I actually want to suggest some good things for the benefit of the construction sector in Bhutan. My short suggestion is about, in connection with Mr. Lama, about since some of you have been here since 70s, like HCC, JP, and then that goes to might have been here since 70s at the time of the REPA project. And in that time, I think I have not heard anything about the activities that you have provided to the construction sector in Bhutan. So, as a suggestion, in future, what I feel is, if the construction, you are being a prominent business and experience in construction sector, if your kind of experience could be shared among the Bhutanese who are young, passionate about learning from the most experienced construction sector. So for that, I think it could be benefit for both the Indian and the Bhutanese construction sectors. And once if you build the capacity of the construction in this society, it will be a pride for the Indian businessmen. That's what I feel.
I think that's what one presentation that's
Anybody else? Yeah, they haven't given business.
Alright, to continue with the next presentation, I would like to call upon Anuj Araiza.
Excuse me, madam. Before that, I was just wondering, just any comments from workers? I had a question for workers.
Would you like to offer?
Sorry?
You want to answer?
that he had already answered, but he can repeat.
In fact, Mr. Lama was asking about the WAPCO's involvement in small or mini hydro projects and how we can help in Bhutan regarding these small projects. You will be happy to know that yes, WAPCO's has been doing mini, micro, small, besides mega projects equally well in almost all parts of India. Very recently, the job of organizing the small hydro sector in Odisha has been awarded to WAPCO's, and this is a very big responsibility which we are right now discharging. At the same time, across the borders of India, in Africa, almost all the places, we have been rendering consultancy work for mini, micro, small and medium scale projects. This answers your first part of the query, that WAPCOS is equally interested in doing the projects which are mini, micro and small. The second part, which talks about our involvement in Bhutan, is entirely dependent on the policy matters of the policymakers, which definitely, I understand, in this congenial environment would be taken up at the right appropriate level. Thank you.
In fact, just to add to this, in the mini, micro, and small hydros, you have many players in India, in fact, and at least you find 10 to 15 very good players who are doing turnkey contracts, including civil and everything they execute. This type of 10 to 15 contractors who are very good are available in Indian industry. In fact, that's the way the contractors can also sit with them in the type of business they are interested in this type of issues.
Let me thank you all for having the patience for the whole afternoon here to listen to all these lovely technical issues over here. Especially we had a lot of insight into the design aspects and also on the construction aspects here, and I think that was naturally very interesting for the people who are involved into it. For others who may not be directly involved into it may be quite enlightening to learn something new about that. So I would like to thank you all once again for being here and allowing us to be here to talk to you, to convey to you. And last but not least, tomorrow we have a session on solar and infra. So anybody who is interested, you're most welcome to visit that. Today evening you are all invited to dinner and cocktails at 7 o'clock. Besides dinner and cocktails, you will have the pleasure of seeing some local dancing over there. So please do come, you're most welcome. Thank you very much for being here today.